Hello students, welcome to Physics Platter. Today in Physics Platter we will be discussing about the basic variables in kinematics. And these are the distance, displacement, velocity, speed, acceleration, force and so on. We will be discussing what these things are, these variables mean, how they are represented and what they actually mean. Okay, so let's start with distance. Okay, so distance is basically nothing but if a particle starts moving from a point, let's say point A particle starts moving from point A and then it moves randomly in any direction and then ends up at point B. Let's say the B is somewhere here. So whatever distance the body traveled in this time from A to B, the trajectory of the length of the trajectory of the body traveled from A to B is basically the distance. Okay, so distance is a scalar quantity. It's a scalar quantity. That means it does not have any direction. While talking about distance, the body can move in any directions. Okay, it has SI unit as meter, simply the unit of the distance. So SI unit is meter. It is represented as S, can be represented as S, X, D and so on. Basically, while representing a variable in physics, you can use any of the letters, that doesn't matter, but you have to be consistent with it. Okay, now let's move on to the displacement. Displacement is nothing but the vector form of the distance. Okay, this is a vector quantity, which means it has both magnitude and direction. Okay, now what it means, basically displacement is the minimum distance between the initial position and the final position of a body. Okay, so here in the previous example we have seen that the particle started from point A and then moved randomly in any direction and then finally ended up at the point B. All right, now what is the minimum distance between A and B? If we draw a straight line from A to B, then this length of AB, is the displacement AB, or rather it's better to say AB. The minimum distance between A and B is called the displacement. It's a vector quantity. It has both magnitude and direction. Again, its SI unit is meter. SI unit is meter, represented as S, X, D and so on, whatever you can use. Generally it is represented as S, X or D. Okay, so in this case, let's say if we put another point C here, then ACB is my distance. ACB, the whole trajectory, the length of the whole trajectory is the distance, whereas AB, the straight line, length of the straight line AB is the displacement. All right, okay, now let's go to the velocity. The next variable is velocity. Again, velocity is a vector quantity, and it is defined as the how fast this displacement of the body is happening. Okay, remember how fast the displacement of the body is happening, or in another way we can say that rate of change of position of the body. rate of change of position of the body in a straight line. Because it's a vector quantity, it is represented as v, can be represented as u, to generally represented used for the to represent the initial velocity, v to be represented for to be used for the representation of final velocity. Generally these are represented as v and u. Okay, so here in my previous example, let's say the particle has gone for from A to B through C at time, let's say 10 seconds. Okay, from ACB, the whole length of the distance ACB equals to, let's say, is we can take it as 100 meters, let's say 100 meter. Okay, and AB, length of AB is, let's say, is 25 meters. Okay, now while talking about velocity, as I said that velocity is a rate of change of position, or we can say that V equals to displacement divided by time. That means here in this case the length of AB divided by time t equals to, we can say that AB is 25 meters, 25 by 10 equals to 2.5 meter per second. The SI unit of velocity is meter per second. CGS unit is centimeter per second, of course. Okay, so velocity is 2.5 meters per second. Displacement, change in time, change in position per time. Okay, that's the velocity. Now, corresponding scalar quantity of velocity is speed. Corresponding, let me write it a little bit to the right so that it's easier to see. Speed. Speed is simply distance. These are again written as v or u. You can write speed is equals to basically distance per time. So speed is a corresponding scalar quantity for the velocity. It's a scalar quantity. That means it has only magnitude, no direction. The SI unit is same, meter per second. So S by T, you can write V equals to S by T. It's a scalar quantity. Okay. So in this case, in our example, A to ABC is the distance. ACB was the distance, which is 100 meter, and the time taken it was 10 seconds. So we can say here the speed equals to, or 100 meters per 10 seconds equals to 10 meter per second. All right. So in this case, the particle went from A to B via C. In this case, the velocity of the particle we have found as 2.5 meter per second, whereas the speed we have found as 10 meter per second. So they are not same. Okay. Velocity is the vector quantity and speed is a scalar quantity. All right. Next variable we will be talking about is acceleration. Acceleration. What is acceleration? Generally represented as S or F. Okay, these two representations are used in physics. So acceleration is given as the rate of change of velocity. It's a vector quantity. It's again a vector quantity. It has both direction and magnitude. The unit is, SI unit is meter per second square. Meter per second square. So the acceleration is rate of change of velocity. Rate of change of velocity. So if a particle starts, let's say if a particle Let me write it here. Let's say a particle was moving with initial velocity u. It's a vector quantity. Of course, it's a vector quantity. Initial velocity u, and after time t, the velocity of the particle was v. Then we can say that the acceleration of the body equals to final velocity minus initial velocity divided by time. So change in velocity per time, all right, v minus u by t, that's the acceleration. Why meter per second square? Because in the numerator we have velocity, which is meter per second. In the denominator there is another second, so meter per second square. Okay, that's the unit of acceleration. All right, last one we will be talking about, the last variable we will be talking about is force. Force. What is force? Represented as generally F. It's a vector quantity. Okay, so it is again a vector quantity. The SI unit is Newton. What is force? Basically, it's a physical quantity, or we can say that it's an influence, external influence needed to change the position or to bring a body or to change the motion of a body or to change the shape of a body. All right, so it's an external influence by which you can change the motion of a body, motion of state of rest or state of motion of the body, or the shape of the body. All right, from Newton's second law we know that F equals to m into a, or mv minus u by t, rate of change of acceleration. Okay, so that's the force. Now I will make a table to represent the relationship between these quantities. All right, so let me write like this. Here the distance or displacement velocity, acceleration, and force. Displacement is represented as S or X. I will write it X here. SI unit is meter. Velocity is represented as V, given as change in the displacement per time. So we can write x1 minus x2 divided by t. SI unit is meter per second, which in the differential form we can write that dx dt. Acceleration A, SI unit is meter per second square, represented as final velocity minus initial velocity per time, or rate of change of velocity. In the differential form we can write dv dt. All right, and then force F, represented as F. SI unit is Newton, given as ma, or m, a is dv dt, so dv in the differential form dv dt, or we can write dv, v is dx dt, so d square x dt square. All right, so that's my table showing the relationship between the basic variables in kinematics: displacement, velocity, acceleration, and force. And these are all vectors. All right, and corresponding their corresponding SI units. All right, so that's all. These are the basic variables in the kinematics that we will be using in our next lectures to solve the problems in kinematics. I hope you have understood this video. If you have any question, queries or suggestions, please write in the comment section. All right, that's all for today. See you in the next video. Till then, take care.